Hi guys, I'm your biology teacher, Miss Finley. All right, this is our first video, and it's just an introduction to what we'll be learning. All right, the first thing I want to say is good things, good grades come to those who study. Okay. With that being said, welcome. I want you guys to write down, get a loose leaf of paper and entitle it warm up. I want you to write down 2 truths and a lie, and we'll talk about it at our face-to-face meeting. All right, things that you need to do to be successful in this class is you need to do all the required work. All right, as long as it's assigned, then you need to do it. I believe that everything I give you has immense learning value, and so it's important for you to do everything that you're assigned. All right, don't ask if it's graded. Don't ask any of those questions. Just get it done because there's something in there that I think will help you in the long run. All right, seek help when you need it. Make sure if there is something that you don't understand, you ask me. All right, first and foremost. Be honest. You know, this is a very unique time, and or trustworthiness is going to be necessary. All right, so be honest with your work. Honestly, do your work at home by yourself and ask me for help if you need it. Come prepared every day, and that means getting your homework done. That means reading ahead, reading over. Okay. Trust me, trust the teacher, trust the process. Okay. I've done this a few times now, and I think we're in a sweet spot. So trust that I know what I'm doing, and I'll get you prepared for your EOC. All right, read over class material constantly. Always make sure that you're reading over your class material. All right, the numbers in biology, if anyone cares. You have an EOC at the end of the year. It's graded on a scale of 1 to 5, where a level 5 is superior command of knowledge and skills. All right, and a level 1 is a limited command of knowledge and skills. And a level 1 really does mean that you don't necessarily, you're not grade level proficient. So no one is trying to be at a level 1. All right, we're all trying to be at a level 3 or higher. All right, so that's our goal. You could set your goal for a 5 if you know that, you know, you've got this, you love science, this is nothing. But if if science comes a little bit harder to you, I want you to at least set a goal of achieving a level 3 or higher. Okay. All right. Our first topic is the nature of science and the scientific method. It's very straightforward, you know, theory. I have a tendency of highlighting my vocabulary in yellow. So anytime you see something highlighted in yellow, it's probably a new vocabulary term that you should be familiar with. Right? A theory is an explanation of a natural phenomenon supported by many observations and experiments over time. All right. For example, the cell theory or the theory of evolution. So as for these notes, guys, I need you to write them down. For the most part, verbatim works fine. But if you feel like you can capture the sentiment in shorter amount of words, then be my guest. All right. A law describes a relationship under certain conditions in nature. For example, the law of conservation of matter. All right. A law doesn't always explain why something occurs. It just describes a relationship. All right. And theories don't become laws, and laws don't become theories. All right. They're separate things. All right. The scientific method is based on experimentation. The development of an experiment tends to follow the scientific method. There are 5 steps. The first thing is you ask a question, you conduct background research, you construct a hypothesis, you test your hypothesis in an experiment, you analyze your data, you draw conclusions, and you communicate them, and you test again if necessary. So in asking a question, this always begins with observation. You see something and you wonder why that happens. All right, so an observation is information that you use your five senses to collect. All right. An inference is using what you have observed along with prior knowledge to draw a conclusion. All right. So an observation is it's factual. You see it, hear it, taste it, smell it. An inference is an assumption. So look at this picture, and I want you guys to take a moment and make some observations and make some inferences. Okay. All right. So you could pause. All right. The video is gonna go because my goal is to make all these videos shorter than 15 minutes. So I'm gonna go, but you guys can pause as necessary and do what you need to do. All right, forming a hypothesis. A hypothesis is a testable prediction based on observation that often describe a cause and effect relationship between variables. I prefer that you write it in the if-then format. If I do this, then that will happen. All right. The independent variable is the cause. What are you changing? The dependent variable is the effect. What do you expect to happen? All right. If I study daily, then I'll earn an A. What are you changing? Your study habits. What do you expect? Earning a good grade. So again, the independent variable is a part of the experiment that the variable is deliberately changing. I say independent variable. This is usually on the x-axis of a graph, right? The dependent variable is the part of the experiment that is being measured. And this is usually on the y-axis of a graph. And I take the time to talk about this now because moving forward, when you're given an experiment and you're given a graph, I don't want you to have to refer to me to find out what goes where. I want you to be able to sit and say to yourself, what is the independent variable? What am I changing? That should go on the x-axis. What is the dependent variable? What am I measuring is another way I like to look at it. And that goes on the y-axis, all right? So again, we talk about these things early because these are foundation skills that you will carry with you through the end. Other variables in an experiment are your controls, your constant, your experimental group. A control group is one that you use for comparison. Usually no changes are made to this group. The experimental group are the ones that are exposed to the factors that are being tested. So if you're testing how different types of nail polish work, right? The experimental groups would be all the groups that have the different types of nail polishes, right? A constant is a factor that remains fixed during the experiment while the independent and dependent variable changes, right? So the constant does not change. It remains the same. So again, if you're testing how effective the different types of nail polishes are, you are looking at using the same person, using the same amount of coats, using the same base coat, the same top coat, drying it in the same way, giving it the same amount of time to dry. All right, so constants are things that remain fixed during the experiment. Look at this picture again, make some observations, make some inferences, okay? And have that to share with me. So you're writing this down and you're making sure that if I call on you, if I say, hey, Ian, what were 2 observations that you made from the picture? You'll be able to tell me. All right, that's it. All right, we have our first video and it's done. And it took us less than 10 minutes. All right, guys. So make sure you have everything copied down. See you in class.